Good day, everyone. Welcome to today's class. My name is Abundant, and in today's class, we'll be talking about hybridization. I'm very sure we've heard about hybridization and we know a little or even more about it. So, I'm going to explain what hybridization means and its types. All right, so when we talk about hybridization, it is the mixing of orbitals, okay? Mixing of orbitals to form a new orbitals, which is known as hybrid orbitals. Okay, let's write it. All right, this is the mixing of orbitals to form a new hybrid orbitals. So this is hybridization. It is the mixing of orbitals to form a new hybrid orbitals. And note, after hybridization, the orbitals that are formed are called hybrid orbitals. So after hybridization, the orbitals formed are called hybrid. Okay, hybrid orbitals. Yes, so the orbitals formed are called hybrid orbitals. Okay, when orbitals are being mixed together to form a new hybrid orbitals is what we refer to as what? Hybridization. So under hybridization, we also have its types. Okay, not the types of hybridization. The types of hybridization. So one, we have the sp3, we have the sp2, and we have the sp. All right. So these are the major hybridization that we have. We have the sp3 hybridization, we have the sp2 hybridization, and we also have the sp. Now, I'm going to explain some things where sp3 hybridization can be found, where sp2 hybridization can be found, and where sp hybridization can be found. All right, so this is the major hybrid orbitals that we will be majoring on. Okay, so these are what the three types of what hybrid orbitals. So now I want you to understand that we have the spvf, okay, orbital. So note that in p it has what? It has three sub level what orbitals. Okay, all right. So and I'm having p now. This is 1 and this is 2. 1 2 3. So we can now say that what? Px1, p what y, okay, py, and p what z. Do you understand? Now leave that one for JAMB. Let's come back here. Look at this. This is an hybrid orbital. Okay, after the mixing of hybridization, or the mixing of orbitals, okay, the new orbital that is formed is what we refer to as what? Hybrid orbitals. So these are what? The hybrid orbitals that we have here. So what next? We are going to look at the types of hybrid orbitals, which is this. Okay, we look at the number of orbitals that are in each of the hybrid orbitals. We also look at the shape, which is also known as the geometry. When we talk about geometry, we're also talking about the shape. We also look at the bond angle, okay, and we also look at the example of compound that these hybrid orbitals can be found. Firstly, we have the sp3. So the number of bond orbitals, the number of orbitals in sp3 is what? 4. How did I get 4? I know you are confused, or probably how did this guy? I'm going to explain. Calm down. So in sp3 we have 4 orbitals. Let me explain. This is sp3, right? Look at the orbitals here. We have s and we have what? P orbitals, right? Look at this. These p orbitals have 3. So can I say p plus what? P plus p. Okay? So summing the 2, mix the 2 together, we have what? Sum it 1, 2, 3, 4. Therefore, sp3 has what? 4 what? Orbitals. Okay? Now for sp2, I'm sure you know this one now. There's no need for me to explain. You know this one. sp2 has how many orbitals in total? It has what? 3. So we have what? We have s plus p plus p. So total of this is what? 3. We have sp2, which is what? 3. And we have our sp, which is what? 2, right? We have s plus what? P. That is what? 2. Now, let's look at the shape of each of these orbitals. For sp3, the shape of sp3 is tetrahedral, okay, or tetrahedral, anyhow. So the shape of sp2 is what? Is trigonal, okay, planar. Okay, the shape of sp is what? Linear. It has a linear shape, all right, or geometry. So for the bond angle, the bond angle for sp3 is 109.5 degree. For sp2 is what? 120 degree. And for sp is what? 180 degree. Right, you know this. So these are things JAMB will ask from you. These are the major things JAMB will ask you, and I'm sure you know this already. Okay, I've cleaned this one. I'm going to rewrite. These are the things JAMB will ask you. Linear. Okay, we have done the hybrid orbitals, the number of orbitals, the shape, the geometry, the bond angle, and you are done with that one. So this one, example of compound that can be found, that these hybrid orbitals can be seen. Now, note that sp3 can be seen in alkenes or cycloalkenes compound, or it is always bonded to a single bond. To a single bond, we have C, we have this. All right. When you see a compound bonded by a single bond, the hybrid orbital or the orbitals functioning there is what? sp3. Or better still, the trick is when you notice that this one belongs to the alkane. You know, alkane means what? Single bond. Cycloalkane, just like alkane in a ring form, is what? Is also what? Single bond. All right. So therefore, we can say that this sp3 can be seen in alkane compounds, cycloalkanes. Yes. So in sp2 is a different case entirely. When you see sp2 can be seen in alkenes, or when there is what? A presence of what? Double bond in a what? In a compound, it is what? That compound is what? sp3 hybridized. Or when they are what? When they are bonded to what? With double bond. All right. So if I'm having something like this, it is what? It is what? sp2 because of this double bond. So this can be seen in what? Can be seen in, for sp2 can be seen in alkenes. All right. So it can be seen in alkenes and can also be seen in carbonyl group. Can also be seen in carbonyl group. Okay. Remember that carbonyl group. Okay, let me put like this. This one is single bond. So carbonyl group has the formula like this. All right. This is carbonyl group for you. C double bond O. All right. So for this one we have sp. sp can be seen in what? In element or compound that has what? Triple bond, or they are bonded with what? That has triple bond, presence of hair. So that one is what? Is alkyne. Example of that one can be what? Alkyne. We can also see that one in nitrile. Okay, nitrile and what? Alene. Okay, alene and alene. We have alkyne. You know, alkyne is C, this C, bonded to with triple bond. This one, okay, this one is C triple bond N, and this one, all right, so can also be seen in alkene, in alene rather. So these are the compound that these bonds are what? Hybrid orbitals are what? Are present. So for sp2 we have sp2 is from this place ahead. So this one is what? Sp is for sp. All right, it's for sp. All right, so we are going to look at the bond length of these hybrid orbitals. I forgot to add this one. So the bond length of each of these hybrid orbitals. For sp3, all right, it has what? 154 nanometer. For sp2, 130. For sp 100. Take note of this. Then the longest is what? sp3, followed by what? sp2, followed by what? sp. So I can say that my sp3, all right, is greater than sp2, greater than what? sp. All right, which means that my sp3 is greater than sp. sp2 is also greater than what? sp. All right, so this is what? The bond angle. You have to take note of this. All right, so for this now, I think we are done. Let's answer this question. It says, when numbered accordingly, what is the hybridization of the fourth carbon in one butene? When numbered accordingly, what is the hybridization of what? Of the fourth carbon in one butene? The first thing we are going to do is to draw the structure of one butene. Now, I've not taught you guys IUPAC nomenclature, but I'm going to drop something. So just a take home. If you see anything like ENE, know that it belongs to the group alkene. If you see YNE, it belongs to the group alkyne. And if you what? CANE belongs to the group what? Alkane. So this one says that when numbered accordingly, what is the hybridization of the fourth carbon in one butene? And take note that but in organic chemistry means what? 4. That means we have 4 carbon. All right, 4 carbon. Let me give you another one. When it is 1 carbon, I'm already teaching you organic chemistry, IUPAC nomenclature. When it is 1 carbon, we call it what? Met. When it is 2, we call it what? X. When it is 3, we call it what? Pro. When it is 4, we call it what? Boots. When it is 5, we call it what? When it is 5, we call it pent. When it is 6, we call it X. When it is 7, we call it X. When it is 8, we call it oct. When it is 9, we call it non. When it is 10, we call it dec. When it is 11, we also call it on dec. When it is 12, we call it dodec. Like that, was like tridec. But for your level, stop at what? Dec. All right. When it is 1 carbon, it is dec. All right. It is met. Now another thing is check the bond angle. All right. No, check the functional group. Does it have a single bond, or does it have double bond or triple bond? If it have what? If it has single bond, it belongs to the group alkane. It belongs to the group alkane. And what do? We'll pick the last 3 letters from here. Okay, if it is 1, we add it to it. It becomes what? Methane. So if it is 2, and you've checked that if it is 2, you know that it's X. And when you check, you now see that it has what? Double bond. Just know that it belongs to the group what? It belongs to the group alkene. Alkene. All right. Just take the 3, add it to it. It becomes what? 18. All right. Do you get it? Like that, like that. If it is if it have triple bond for alkyne, that will be alkyne. All right. Just take the 3 and add it. It becomes what? Ethyne. Is it clear? So that's how to name an organic compound. So for this, let's leave this. All right. So let's leave this and go to the naming of this one. Boots. That means we have 1, 2, 3, and 4. After that one, we look. See, if you look at this one, it said 1 butene. That means that 1 butene. That means that it is what? The group alkene, and the double bond is attached to the carbon 1. Carbon 1, and that will now be what? Put it here. If I start from here, my double bond is here. But if I don't start my numbering from, if I start from here, it will be here. It's still the same thing. So let me start from here. Okay, that will be what? Butene, right? This is what? This is 1 butene. 1, 2, 3, 4. 1 butene. Now, and the question says, when number accordingly, what is the hybridization of the 4th carbon? So know that this to this is what? Is what? sp2. So this to this sp2. Then they said one number 1, 2, 3, 4. See this one? They said what is the hybridization? And I've told you that for compound that have single bond, they are what? They are sp3 hybridized. So see this, it is what? It is what? It is what? Single bond. So therefore, the 4th carbon is what? Is sp3 hybridized. Why this one is what? sp2 hybridized. Is it clear? This one too is also sp3 hybridized when it has single bond. So that is for this one. So the next one, it says underline the compound that bears the shortest carbon to carbon bond length, all right, among the following. Okay, and I've told us that it follows this pattern: sp3, sp2, and sp. That means the shortest is the sp, and they are asking us for what? The shortest. So, and I know that I've told you that this sp belongs to the group what? Alkyne. Abi can be seen in the compound alkyne, the group alkyne. So look at this. We have cyclopentene, pentane, ANE. We have methane. We have heptane. We have 2,2-dimethylpentene. So looking at this, sp is what? Shortest. Therefore, this will have the what? The shortest bond length. For the next one, the 3rd question, it says, what is the value of the bond angle of H to CH carbon? Just what's the bond angle, all right, of this bond as found in methane? You know that methane is what? This is for methane, all right. This is methane. Met has 1 carbon. This is methane, all right. So now, so what is the value of the bond angle? And I've told us that for this, if you see this, you think it does not have, but still methane. Say for methane, okay, for bond angle in methane, you know, methane belongs to the group alkane. So for the bond angle of this methane, so 5 belongs to the group alkane, is what? Is what? That time, if you could remember vividly, I said it is what? 109 for what? For alkane, 109 degree. Thank you. This is another question, question 4 and 5. So looking at this question, it says the percentage of P character in sp3 hybridized carbon is. Now let's solve it. Solution. All right. So to solve this, you say percentage of P character, which is that is what we are looking for. Okay, is equal to what? Number of what? Number of P all over what? Total number of what? Orbitals okay, times what? 100. Times 100. You know, percentage is always times 100. So now let's look at, so my number of P now is what? Look at this, sp3. It tells you that it has what? S plus P plus P plus P. So my P is what? 3. So that is 3. Then number of orbitals, we have 1, 2, 3, 4. So my number of orbitals in sp3 is what? Is equal what? 4. Abi? So my percentage of P character will now be what? That will now be percentage now will now be number of P is what? 3 all over what? 4. That will be times what? 100, which is what? 75%. So that is that. Okay. What if they say that you should look for the number of what? Of S in sp2 hybridized. Okay, number of S in sp2 hybridized. You can do this by yourself. You can pause this video and solve it, then drop it in the comment section. So let's do this. Say the number of what? The percentage of P character of S character. So that will not be percentage of S character. All right, will be what? Will be number of S all over what? Total number of what? Total number of what? Of orbitals times what? 100. And my number of S in sp2, number of S is what? Just 1. That will be 1 all over. Total number of orbitals, that will be what? 3, right? S plus P plus P. 1, 2, 3. That will be 3 times what? 100. Then you press your calculator, you get the answer. All right. So for this one, the third one says sp2 hybridized has dash geometry. I've told us that when you hear the word geometry, it's still the same thing as shape, all right, with dash bond angle. All right, sp2 hybridized carbon has dash geometry with dash bond angle. So what's the answer? I know you know this already, right? So I've told us that for sp3 is tetrahedral. So example of this is your methane, Abi. So that's how you say methane is what? Is tetrahedral in shape. All right. So for my sp2 is what? Is trigonal planar. Okay. And my sp is what? Is linear. It has a linear geometry. And sp2 has trigonal planar and sp3 has what? Is tetrahedral in geometry. All right, with dash. So for the bond angle, I have told us that for sp3 has what? 109.5 degree. Then sp2 is what? 120, and my sp is what? 180, since it is what? Linear. So therefore, my sp2 hybridized carbon has what? 120. Okay, the shape first is what? Trigonal, right? Trigonal. Okay, then planar. Then with my bond angle off, my sp2 has bond angle of what? 120 degree. Now, what are we going to do? I'm going to treat some past question, JAMB past question with you before we call it a quiz. All right, so let's do this together. All right, so let's treat past question, the JAMB past question. It says the carbon atom in ethane are what? Carbon atom in ethane are what? Okay, we are talking about the hybridization now, and I know you know the answer because I have taught you. So just pause the video and drop the answer for this in the comment section before I solve it. Have you done that? Okay, let's solve it together. So for ethane, For this, it has what shown that it belongs to the group alkyne. And if the table I gave other earlier, I said alkyne, all right, alkyne can be seen is what? Any alkyne are what? Are S, all right, sp hybridized. Are sp hybridized. Remember that alkyne has what? Triple bond. They are what? Triple bonded. So any compound that is triple bonded has what? sp hybridization. If it is single bonded, it has what? It has what? sp3. sp3 for single bond, sp2 for double bond. All right. So the question says the carbon atom in ethyne are what? A. The correct answer is A. sp hybridized. Thank you. The next one, it says the hybridization of each of the carbon atoms in ethene is the hybridization of each of the carbon atoms in ethene. We have ethene. Okay, note that it has what? It has what? Double bond. It belongs to the group what? Alkene. All right. Belongs to the group alkene, and I've said that if compound belongs to the group alkene, they are what? They are what? sp2 hybridized. So this one is what? sp2 hybridized. Then the next one says, which of the following orbitals of carbon are mixed during hybridization? Which of the following orbitals of carbon are mixed during hybridization? All right, so let me explain. They said which of them are mixed. Okay, so for carbon now, note that carbon is what? C, it was 6. Hydrogen, helium, lithium, beryllium, boron, carbon. All right, carbon is what? 6. Okay, so I can now say my 1s2, 2s2, and 2 what? All right, 2p what? 2. Abi, 2 plus 2, 4, plus this one, 6. And remember that my carbon, my P, have 3 sublevels. Okay, so I now have my 1s2, okay, 2s1, 2px1, Abi, then 2py1, and 2 what? 2pz1. Okay, now if you look at this, the question says which of the following orbitals of carbon are mixed during hybridization? This one and this one is mixed during hybridization. So the carbon that is mixed, the orbital that is mixed is what? 2s and what? 2p. Hope you understand. If you split it, you have 2x and 2p. All right, it is what? Mixed during hybridization. So another one says the orbitals that overlap in methane. The orbitals that overlap in methane. All right, the orbitals that overlap in methane is what? The orbitals that overlap in methane, A, we have S and S. B, we have sp2 and what? S. C, we have sp3 and what? S. And my D is equal to what? sp and what? S. The orbitals that overlap in methane. Please take note that methane, all right, first thing you have to notice, methane belongs to the group what? Alkane. And you already know that alkane are what? sp3 hybridized. Now you've known one of the what? Orbital that what? That overlaps. Now for methane we have this. All right, so this orbital is overlapping. All right, this orbital, they are overlapping, sp3 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 sp3, they are overlapping to each of the what hydrogen. So this hydrogen is what is s. All right, s. Okay, this one is what sp3, the bond sp3, because single bond belongs to the group alkene sp3, then it overlaps to this, to what s orbital. It overlaps what to s orbital. So the orbitals that overlap here is what sp3 and s. Okay, just understand. Thank you so much. Thank you for watching. Subscribe and see you later in our next class. Bye.